All right, good morning everyone. Let's see, there we go. My name is Martin. I'm the founder of Scandinavian Drone. So we're one of the distributors for Yellowscan up in Scandinavia. We're based in Norway and Sweden. So this morning I'm going to tell you a quick story about high mountains, about cold, snow, hazardous roads, and just to make sure that everyone gets a little bit of what they're here for, we're also going to speak about LiDAR. So I can start with just a quick backstory. This was last summer. One of our partners called Orbiton in Norway phoned me up and told me that they were working with this project together with the Public Road Authority. So going back a few years, the Public Road Authority started a project with trying out different type of systems to monitor and assess road conditions up in the mountains. So basically, the Public Road Authority is a public company in Norway. They're responsible for maintaining all of the public roads. And of course, this provides a lot of challenges with being in Norway, since this is a country that is very exposed to harsh weather conditions. You have cold, you have wind, you have a lot of snow in the winter, of course, and not the easiest terrain. So you have the mountains and the fjords, so you have a lot of challenges in terms of keeping the roads safe, more or less, from different hazards. So one of the main objectives for the Public Road Authority, of course, is to proactively monitor and react to different type of hazards, and especially when it comes to snow and avalanche hazards. So they need to make assessments whether or not the roads are safe to open up again, and whether or not they are safe to clear from potential avalanches, or basically start clearing after an avalanche or snow has covered the road. And this, of course, also applies just as much for landslides and rock falls and things like that. So wherever you're located, you can have the same type of hazards from those as well. So normally the traditional methods are, of course, using binoculars and just traveling actually into the hazardous area by foot or by skiing or snowmobile, etc. And of course, it's always nice to go for a nice walk or a snowmobile ride in the mountain, but it's also dangerous. And the same goes for helicopters. It's sometimes quite dangerous. You're exposed to the environment. And it's also very expensive. So based on that, the Public Road Authority wants to assess and evaluate new type of methods. And of course, many of those methods are using UAVs with different type of sensors. And hopefully these sensors can make sure, the UAVs and the sensors can make sure that they can make faster decisions and also get better decisions. And of course, keep people away from the dangerous area. So I'll just jump right into this. This is the Geosphere Research Project, a project that was is actually led by the NPRA, or the Norwegian Public Road Authority. So it's a project that is partnering up with some research agencies like SINTEF and NGI and NTNU. And the project's main objective is to evaluate the use of instrumented UAVs. So if Roberto down there, can you click the quick link, the YouTube link, and see if it works? We'll play a short video, compliments of the Public Road Authority. All right, so that's how the guys from the geologists from Public Road Authority spends their days. Seems quite nice, not as warm and nice as here, but at least they're out there. So yeah, as I might mention, the goal of this research project is to evaluate new technology and especially drones with different type of sensors. And the goal, of course, is to make faster and better assessments or reduce risk and, in the end, keep the roads open and keep the roads safe to travel. So if we rewind back a little bit, they already started doing some of these tests back in 2016. And this demonstration was basically focused on the different type of UAVs and how they can handle this rough terrain and hard climates and so on. And then a couple of years later, they moved on to another round of testing where they wanted to test a few different sensors. And this one was more focused at the ground-penetrating radar to be able to measure the thickness and composition of the snowpack, and also used photogrammetry to be able to create point clouds and elevation data. And of course, both of these technologies have their benefits, but they also have the limitations. So photogrammetry, of course, is maybe not ideal if you want to use it for creating point clouds and elevation models of very homogeneous surfaces like snow. And also, when it comes to being up in the Nordics, it's also very dark outside a big part of the year. So when you have a lot of snow, it's also very dark. So you have a very, very limited range of when you can actually collect good data. So that brings us to 2021 and the next phase of this project. So this one that we got invited to via our partner Orbiton in Norway, who's a drone operator working for the Public Road Authority a lot. They got invited to join this test with focus on LiDAR technology. So it was a combination of the actual drone and the UAVs and the LiDAR sensor itself, but it was mostly focused on what has happened with the LiDAR technology since, for example, 2016 and up until then. Because there's been quite a lot of development, especially with the sensors getting smaller, lighter, and also more reasonably priced. So this is more or less the reason that they wanted to invite people to come up and demonstrate different systems. So the purpose for the test was to do an overall assessment and evaluation of how everything is performing, the accuracy and the precision, and how well it actually works in realistic scenarios. So up until there we got a total of 7 teams who was joining this demo. So it was different type of operators, service providers, and so on. And the test was ongoing over 3 days in the end of October. So we started to get a little bit of snow, but it's still quite early in the season, so it was a little bit limited on the amount of snow. But they identified 3 different sites at and around the Trollstigen area. And like I showed you in the first image, it's basically the end of a valley where you have this path leading up to the mountain. That's Trollstigen. So this is there we have us. The team that joined here, Kim André and Thomas from Orbiton, and then of course some of you might recognize Pierre over there and myself. And then we have the system that they brought with them. It's the Velos UAV. It's a electrical helicopter drone. And then Pierre brought the YellowScan VX2300 scanner, which is a very competent system. So the test sites, I don't know how well you can see it here, but you have site A, site B, and site C was divided into 2 places. So site A is the first one that everyone got to flew the first day. This was more or less chosen to be able to use as a benchmark for the accuracy and performance of the systems, and also make sure that every operator had a fair chance to get there, set up everything, and just get everything working properly. They also placed the GCPs down here that can be used as a reference, and also to adjust the point clouds. Let's see. And then you had site B, which is located a little bit trickier here, down at this vertical cliff face. So this is a cliff face that is more or less 500-600 meters of a vertical drop, with large boulders and snow coming down on the side and then falling straight down towards the road and the parking. So this was a very challenging place, because you have, in the end of the valley, you have a lot of turbulent winds coming down, and you also set up the base station down in the valley. You have GNSS shadow, you're not going to get that good reception. So while the drone is up in the air and collecting data, the base station is still down there and getting way less satellites. So this up here is the actual flight trajectory that you can see. So it started with having to fly quite far out in the valley and building altitude, and then zigzagging down towards the bottom and capturing data. So this was a challenging site, and not everybody was able to collect good data. Of course, using the VX20 with I think we used 180 degrees field of view on this one, but there was also some different operators that were using like Avia, Livox Avia-based scanners that were struggling to get good coverage on the rock face. And then you had the last sites, which was up at an area where you have more or less snow all year round. So this was basically the only place that we were able to collect data that had snow on it, or snow data. And of course, this site A was quite close to where we had the takeoff location, so that was not a big one. And most operators were able to fly there, and Orbiton was actually the only one who chose to go for site C2, which is more or less 2.5 kilometers up towards the edge of the ridge of the mountain. And up there was a lot of strong winds and turbulence coming over the ridge of the mountain. So they managed to collect data, but then they decided to actually abort the flight about halfway in. But we got some data sets as well, so if anyone is interested, you can also check those out later. And the evaluation of Site C was, of course, to actually get snow data, and using the Public Road Authority used the software Cloud Compare and plug in for this to measure the snow depth, and then also be able to measure volume. And basically, when all of this was done, the operators or the teams delivered all of the data to the Public Road Authority. They went through the analytics and assessed all of the projects, and got some different. I'm not sure if I got all of the slides on this PowerPoint, but still. To wrap it up a little bit, the question, can LiDAR be used to collect snow data? And I would say that definitely the answer is yes. it can be used, but it does need to take into consideration the limitations of both the UAVs, of course, because this is normally you don't fly when you have the best conditions. You really fly when it's harsh conditions, when it's winter, cold, and so on. So while we might think that something like a Matrice 300 is a very rugged and solid platform, and it is, you can still see that when you come up in these mountains, those actually smaller drones have limitations. So in many cases, you really need something like a Velos or upwards, some really large and powerful system that can also, in many cases, carry a little bit heavier payloads. And of course, you have the challenges of collecting good data in bad scenarios, both, as I mentioned, with the GNSS shadows in the valleys, and also you have snow and wind. And then maybe one of the most important thing is to actually have experienced operators. If you go up there and you're used to flying like flat fields and not really used to the harsh conditions, it's a little bit scary, to be honest, sending up equipment high up there and beyond line of sight and so on. So I would say you need to have really experienced operators doing these tasks, both in terms of operating the systems and knowing regulations and so on, of course. And then last but not least, if you want to measure snow depth, you also need to know what is below, what is the bare earth. So one of the most important thing, of course, is to have accurate terrain data, elevation data to begin with, so you can get the correct measurements. So that's more or less it. The final one little thing I can leave you with is, if you want to visit Trollstigen, I would recommend not to visit in October. Visit in the summer, it's much nicer. So that's more or less it. And I'd like to thank you for your attention, and have a nice second day.